welcome to today's video. Today we will be studying electrovalent bonds, and if time permits we will go for covalent bonding as well. So without any delay, let us begin today's video. So first term that comes in our minds by beginning this chapter itself is chemical bond. So what exactly is a chemical bond? Now to understand this thing, first you need to understand why exactly is a chemical bond formed. Chemical bond is formed due to a special term called stability. Everything in this entire universe tries to attain stability. Everything, be it us, be it elements. For example, we try to attain stability. How? We try to attain stability by aiming for something. Suppose I am in class 10 and my aim is something. I am not revealing what my aim is, but my aim is something. So I want to go there, then only I will be stable. Right now I am not stable because I have not attained that aim. Similarly, if an element is at X, its ground state, okay, ground state, that is the current state, okay. Just for explanation, term is ground state. So it will only be stable when it goes to excited state, okay, that is it achieves the pseudo noble gas configuration. So when is an element said to be stable? When it attains your pseudo noble gas configuration. Let us take the example so that it will be easier to understand. Na has got one valence electron, and this one valence electron is disturbing Na. So Na wants to become stable. How it will become stable? It will become stable by losing this one electron. How will it lose? It will lose like this. So it forms a cation. Now this cation has got 2,8, 2,8. Initially it was 2,8,1. Now it is 2,8. 2,8 is neon, right? So will you say sodium and neon are same? No. Sodium ion and neon are not same. Okay. Neon is neon and sodium ion is sodium ion. Okay. It is just achieving the noble gas configuration. So it is called the special term that is pseudo. Pseudo means something not real, but it achieves. Okay. Like you have learned in physics, pseudo force. That is virtual force. So it's kind of virtual. Okay. So this is basically stability. So stability is achieving the noble gas configuration is stability in chemistry. Okay. Now next is chemical bond. So when these atoms attain stability and become ions, they tend to form bonds. Now you will say that do elements attain stability only by forming ions? No, not at all. It can even attain stability by sharing electrons, by losing electrons, ions, that also it will form, but sharing does not form any ions. So basically, stability can be attained in different ways. Not only in this one way stability can be obtained, but only in different ways. Okay, that we are coming to it a little bit later. First, let us understand chemical bond. Suppose there is an element A which has a positive charge. Right now we are talking about ionic, so I am not going to cover it right now. Okay, A positive and there is a Y negative. So this positive will try to attract this negative. So this A will say, hey, you come towards me. Why? Because plus will attract negative, and this negative will also go towards positive. It will not deny. Had it been A positive? Had it been A positive? No. You say, no, I will not go towards you. You are safe. It will not go towards you. Okay. But A positive and Y negative is it? It will say, come towards me. So they together will form a bond and it will form a compound A positive, Y negative. That is a example of electrovalent bond. So this, there is some bond between them. What is that bond? Coulomb force. Actually, it is a force of attraction. We have termed it as Coulomb force. Okay. So what is a chemical bond? How can you define? It is a force of attraction. Okay. It is a force of attraction between two atoms in a molecule. Now, often in a definition, you end up writing two atoms of an element. Often you end up writing this. This is error number 1. Error number 1 that you make in writing definition of chemical bond. First part is right. Electrostatic force of attraction. Right. That is okay. Force of attraction, electrostatic force of attraction. that is okay. Electrostatic is only applicable for ionic, but it is still considered, okay, but still it is considered, but try not to write it. Two atoms of an element, force of attraction between two atoms of an element. This is one error, first error. Second type of error, two molecules of a compound. Two molecules of a compound. These are the two very common errors that is often written in the definition of chemical bond. What is the error? Check properly. Chemical bond, is it only between elements or is it only between compounds? It is for both. Then in your answer you cannot specify that whether it is for elements or it is for compounds. If you are specifying this, you mean there cannot be chemical bond between compounds. You specify this, you mean there cannot be bond between elements. So you cannot write that. And how should we write that? Just do not write two atoms of an element. Two atoms is fine. Write two atoms of a molecule. That molecule can be of an element. That molecule can be of a compound. So two atoms of a molecule together to attain stability. That is known as chemical bond. So how will you write that? Two atoms of a molecule to attain stability or to maintain stability is called chemical bond. Do not specify anything, otherwise there will be a problem. Okay. Now, chemical bond. There are three types of chemical bond: ionic, coordinate, covalent. Three. Okay. Coordinate is also seen as coordinate covalent, because generally in case of coordinate covalent, coordinate bond, we have covalent bond also, because that is covalent. Does not matter. First, let us learn that how can a chemical bond be formed. Chemical bond formation ways. Formation. How can a chemical bond form? Let us learn first about that. How will it form? It can form in three ways. Three main ways. First is gain of electrons. Okay. Second one is loss of electron. Third one is sharing of electron. Clear? So there are three ways. Gain and loss, you can understand very well. It is both for ionic bond. Sharing, it is for both covalent and coordinate. Now sharing has been divided into two parts. Both sharing, okay, that means you can tell it as mutual sharing, okay, and this is one sharing, or you can write it as one-sided sharing, okay. One atom will share a pair. It will be, shared by both, but one will give, completely given by one, okay. This is mutual sharing. Both will give and both will share. This is one will give and both will share, okay. And we are coming to later on. So this is how a chemical bond can be formed and it can attain stability. Now let us get into the first topic, that is ionic bond. Ionic bond. Now by the name only you can understand that ionic bond has got something to do with ions. Ionic bond has got something to do with ions. Yes, it has got something to do with ions. Before we get into the ionic bond, let us define this term. What is an ionic bond? It is also an electrovalent bond. Hopefully you all know that. Ionic bond is a chemical bond formed by the electrostatic force of attraction between cations and anions. Okay? Now I am saying cations and anions just to say, okay, it is one cation, one anion. Cannot be more than that, you can understand that. So it's the chemical bond formed by the force of attraction. What force of attraction? Electrostatic force of attraction. Positive negative charge is there between cation and anion. That is known as electrovalent bond. Now, how to express an electrovalent bond formation? That is very important. For that we will use Lewis dot diagram. But that comes a little bit later. First let us learn what is an cation. Cation is not say much. Cation is an ion that is positively charged. Anion is an ion that is negatively charged. Right? Cation is an ion positively charged. Anion is an ion negatively charged. Positive will attract negative. That forms electrostatic force of attraction, and that gives rise to the ionic bond furthermore. Now the compound that is formed as a result of the transfer of electron from one element to other element, resulting in a formation of cation and anion is called electrovalent compound. Okay. Term 1 under electrovalent bond is electrovalent compound. Electrovalent compound. This you have to remember the definition. Second definition is electrovalency. Electrovalency. Okay, electrovalency. Electrovalency is the number of electrons lost or number of electrons gained. Now, see. Suppose one element is losing 2 electrons. So there has to be the other element accepting 2 electrons. If it cannot, then it has to be 2 elements of the same kind. Like for example, Mg. Mg loses 2 electrons, right, to form Mg2 positive. And Cl can gain only 1 electron to form Cl negative. So when will the electron go? It cannot go into the surrounding. It has to go to some Cl, so another Cl will join it. Clear? So it will be MgCl2. So you have to always check that electrovalency is the number of electrons either gained or lost, and both has to be equal. Both has to be equal, right? In total I am talking about. Okay. In total. If here also electrovalency for chlorine is 2 and for Mg is also 2 electrons gained, 2 electrons lost. Okay. Now if it has been asked electrovalency for each chlorine 1. Each chlorine can take only 1. But electrovalency total is 2. So this is the 2 terms that you need to read under this. First is definition of ionic bond obviously, then ionic compound definition, and then is electrovalency definition. Okay. Next is, why are exactly this electrovalent compound so stable? Simple reason is electrostatic force of attraction is very strong. It needs lot of energy to be broken. It is the simple reason. Next comes the important thing, the most important thing, that is the Lewis dot diagram. Lewis dot diagram. That is also said as electron dot diagram. Now you have got in the syllabus 3 things that you need to draw. What is that? Very easy. NaCl, MgCl2, CaO. 3 things you need to draw. NaCl, MgCl2, CaO. Now before drawing the structures, let me tell you the difference between a parent atom and its cation and anion. You have got 2 differences given in your book, that is sodium and sodium ion difference, sodium and sodium ion difference, and chlorine and chlorine ion difference. Now generally if the question is asked, parameters are given. Like suppose it can be given that sodium and sodium ion differentiate based on color. So sodium is silver grey while sodium ion is colorless. This might be given. Like Cl and Cl minus can be given toxicity. Then Cl minus, Cl is very suffocating gas. Okay, Cl minus is non-poisonous. So this type of questions you have to give. This type of question that might be asked. Okay, this type of questions might be asked in the exam. Okay, so I am just writing out over here. This is, let us take color. Color. So this is silver grey and this is color. Okay, colorless. Let us take this is toxicity. Toxicity. Okay, this is toxicity. Toxicity means how harmful it is to us. So Cl is a very poisonous gas. It suffocates. Okay, but you are not going to write suffocating in case of toxicity. I just now mentioned. So I was sorry for that. Okay, I did not intend to say that. So it's poisonous. Do not write suffocating because suffocating will go well with odor. Okay, not with toxicity. So do not write suffocating. Okay, just sometime before I say suffocating, so don't write that. Okay, ignore that. Cl minus is basically non-poisonous. Okay. Cl minus is non-poisonous while Cl is poisonous. So this type of differences will be asked in the exam and you have to write it accordingly. Maybe parameters are given, if not given, then go for the easiest one. Like Cl is a neutral one, this is a negatively charged, and is a neutral one, is positive charged. Okay. Now let us get into the electron dot diagram. Electron dot diagram or Lewis dot diagram. First diagram is NaCl. Now whenever dot diagrams are asked, then you need to properly see that NaCl, Na only outermost, Cl also only outermost. Rule number 1, outermost you have to show. First one. Second, Na and Cl both cannot be shown by the same. Like if I am showing Na by a dot, Cl can have to be shown by a cross. Both cannot be dot dot. Otherwise, how will you understand which one is sodium, which one is chlorine, right? So one has to be dot, other has to be cross, dot cross. Okay. Now, if it is a structure, then only the product has to be drawn. If it is a formation, then first part of the reaction combining, sharing, then it is the product. I am showing both. First, let me show you the formation. So for formation, you have to draw two structures. What is the two things you have to draw? First is Na, you write like this with 1, and you write Cl like this. So I am drawing like this, 1, 2, 3, 4, 5, 6, 7. Okay, then you have to show with the arrow, this comes here. Okay, now you can write it like this, or you can even give an arrow below and you can write it. Your choice. Okay, so what it will form? Na, third bracket positive, or you can write just Na, it is your choice. This is completely optional. These signs are completely optional. Then you have to write Cl, 1, 2, 3, 4, 5, 6, here 7, here 8, and here negative. If this is not visible, I am zooming it over here again. I am writing, not zooming, sorry. Cl, this is this. Oh, sorry, wait. It was not like that, right? Now so this is 1, 2, 3, 4, 5, 6, 7. Okay, so this is like this. Okay, so this is the structure of NaCl. NaCl structure somewhat looks like this. Okay, this is not cross, so don't check this. Not cross actually. Okay. So this will form like this. What is happening? This is dot, so I wrote all dot. One cross got from here, so I have to show that cross over here. 1, 2, 3, 4, 5, 6, 7, 8 electrons are there. Okay, and this minus charge over here is very important. You can get the minus outside, you can get the plus charge also outside or inside. Then you don't need to use the bracket. Okay, but it's yours. But here you have to write the outside the bracket. That is very important. Or this structure also to write outside the bracket the charges. So this is the thing. That is the first case formation. This is the formation. Entire thing has to be drawn. And in product, if it is a structure, then only this part. For structure, only this much part will do. This is the structure, this is the formation. For formation, only one step is added, that is the arrowhead you have to show. So this is the NaCl. Now let us go to the next part. Okay, next is MgCl2. Next is MgCl2. So as I have already told that Mg has got two, Cl has got only one capacity to enter one electron. So one will enter here. Where will the other go? Other cannot go. Dissipate in the air. It cannot go there. So there will be another Cl that will be taking part over here. 1, 2, 3, 4, 5, and this electron will come over here. So ultimately there are two things that is happening. Okay. Now how to write this two? You can write it simple. You write one Cl at this side. 1, 2, 3, 4, 5, 6. 7, 8, negative. Now in between write Mg, give bracket 2 positive. Then after that again write another Cl. Okay, like this. I did not have space, I am writing below. So cross, 1, 2, 3, 4, 5, 6. Okay. So this is the structure of MgCl2. Okay. So this is the structure of MgCl2. What if redox reactions are asked? Or show that this is a redox reaction, then in that case what to do, I am telling a little bit later. Okay, first let us complete this, then I will be saying what to do in that case. Last one is CaO. MgCl2 done. Now we are doing CaO, the last one. Calcium oxide is again a very easy one. Calcium oxide, so it's basically Ca having 2 electrons and O having 1, 2, 3, 4, 5, 6. So capacity is 2. So one moved over here, another one also moved here. Okay. So what is the formation? Here 2 positive, and here it will be O. 1, 2, 3, 4, 5, 6. That. So this is the calcium oxide. Basic. Understood? This is the basic. Now redox reaction. Redox reaction. What is a redox reaction? Redox reaction is basically where oxidation reduction occurs simultaneously. Now every reaction is a redox reaction. Every reaction is a redox reaction. Whatever reaction you take, every. Okay. So let us take NaCl formation. How to get the complete equation? Redox reaction will also be structured. Na gets 1 electron it loses, to form Na plus. It loses one electron to form Na positive. Cl on the other hand gains one electron to form Cl minus. Right? Now see, this is one part, this is one part. But if you write the basic reaction, it is Na plus Cl2 forms 2 NaCl. 2 Na plus Cl2 forms 2 NaCl. You know the reaction. Now how do you getting that? If this is Cl, then there should not be Cl2 coming from. Where did the Cl2 come from? Right here Cl2. Okay. So that's Cl2, here it will be 2 C, here it will be 2. Now we say why 2 electron? Cl2 means Cl, right? So 1 Cl can get 1 electron, 2 Cl will get 2 electron. How many ions will you form? 2. It's 2. Done. Now what to do? Now add up these two reactions. Add up these two reactions. You will get a value. Okay. Now you will see, upon adding up the reaction, you remain with 1 electron. You remain with 1 electron. Now you say, what will I do with the 1 electron? Just remove the 1 electron. How will you remove the 1 electron? Put a 2 over here, put a 2 over here, put a 2 over here. Done. Then this will get cancelled. So what are we remaining with? 2 Na plus Cl2 forms 2 Na positive and Cl negative. Okay. So that is, we are taking the 2 common. Just like maths we do, we are taking the 2 common. So it's ultimately the reaction comes as 2 Na plus 2Cl2, 2 NaCl. Right? NaCl actually this, but we do not write Na positive, so it's very odd looking. So we write like this. So did we get the reaction? This is the reaction that I told you, and this is how we are getting. So this process is called oxidation, loss of electrons is oxidation, this process is reduction. So oxidation, reduction occurring simultaneously gives you redox reaction. So this is the part that you need to remember from ionic bond. So ionic bond has got this much part. The next part, that is the covalent bond, which I am just going to give a brief introduction about covalent bond. Okay, in the later part of this video, not now. Now we are not completed with ionic bond reaction. Conditions for this that we are not yet told. What are the conditions? Now you check. We have done so much things. What condition could you see? Check this reaction properly. What can you guess from here? Electrons are being lost. What periodic property can you relate? IP. So if IP is more, then what will happen? Electron losing capacity will decrease. So what has to happen? Low IP. So condition is low IP. Then electron negativity difference has to be huge, because if there is slight electronegativity difference, it becomes non-polar. If it is not there, it is non-polar. Right? So we don't want polar, non-polar, we want ionic. So huge electronegativity difference has to be there. And if IP is low, EA has to be high. IP is low, EA has to be high, so that anion can be formed easily. More energy release, more strongly the bond is bonded, bond order will become more. So what are the conditions? Low IP, high EA, large electronegativity difference. That are the conditions of ionic. Next, let us begin now with covalent. I am not telling in detail, I am just giving a brief gist. Chemical bonding. Second bond is covalent. Covalent. Very important part is covalent. What exactly is a covalent bond? It is a mutual sharing of one or more pair of electrons between two atoms. Okay, the bond that is formed between these two atoms are called covalent bond. Now covalent bonds are divided into two further bonds, that is polar, non-polar. Also it is single, double, triple. Single, double, triple is easy, but covalent polar and covalent non-polar is an important thing, and you need to read it properly. Then you will learn the conditions of covalent bond in the next part, and the ultimate part that will come at the last of this is comparison between electrovalent and covalent compounds. Okay, we can discuss electrovalent property now, covalent property when you learn covalent. So let's just brief about some properties of electrovalent compounds. Like in MCQ the question might come, which of the following is not a property of electrovalent compound? Not a property, then in that case you have to identify which one is not. Which are the properties? Basic property, that is, it has high melting and boiling point, result remains same, electrostatic force of attraction is high. So more energy needed to break it, right? Next is, it is generally solid in state. Generally it is solid in state, so it will not be volatile, so it will be non-volatile. Generally I am talking about, exception always has to be there. So it is generally solid in state. So since it is generally solid in state, then it will not be volatile. It is non-volatile generally. Next, the important thing is rate of reaction is very fast. Why? Ionic reactions are very fast. Okay. Next is it is soluble in water. You see ionic compounds are soluble in water, but not soluble in organic solvents. Why? Organic solvents are covalent solvents and polar covalent. Okay, so they are not soluble in organic solvents but soluble in water. So these are the some highlighted points of this. Okay, highlighted points. Another highlighted point is good conductor of electricity, good conductor of heat. These are all highlighted points of ionic compounds. Another question that came in my mind is that which one is the most ionic compound? I think I had told this in the periodic table as well. Which one is the most ionic compound? Then that has to be the most electropositive element and the most electronegative element. What is electropositive element? An element that can lose electron is electropositive. One which can gain electron is electronegative. Okay. Which one is the most electropositive element? Most electropositive element is located at the bottom of the group 1, right? Bottom of the group 1. So if we look at the bottom of the group 1, then who is that? Cesium. And who is the most electronegative element? First, fluorine. So what is the compound form? CSN. So it is caesium fluoride. The most ionic compound. Okay, most ionic compound. So this is the thing that you need to remember from this chapter. That ends the ionic compounds completely. Next video I will be discussing about the covalent bonding in detail. I have briefed it already, but I will be telling about it in details in the next video. So see you all in the next video. Hope you all have enjoyed watching the video.